Hi, good day everyone. I am Carmela F. Ambrosio, and for today we will talk about coefficient of determination and standard error of the estimate. So this topic is divided into two parts. The part 1, which is the coefficient of determination, is what I am going to discuss, and Ms. Roxanne Cruz will discuss the part 2, which is the standard error of the estimate. Now, to begin, let us introduce first the types of variation for the regression model. The total variation is the sum of the squares of the vertical distances each point is from the mean. The total variation can be divided into two parts: that which is attributed to the relationship of x and y, and that which is due to chance. The variation obtained from the relationship is called the explained variation. On the other hand, the variation due to chance is called the unexplained variation. So the total variation is actually the sum of explained variation and unexplained variation. It is also called SST, or the total sum of squares. And the explained variation can be explained by the relationship between x and y. It is also called SSR, or the sum of squares regression. On the other hand, unexplained variation is computed due to chance. So basically, unexplained variation is the error component of the regression equation. It is also called SSE, or sum of squares error. So to have a more deep understanding about this concept, let's take a look at this illustration. So we have here a scatter plot. Let us consider all the plain blue points here as our data. The slanting color green line represents the regression line, designated as y prime, or also known as predicted value. And this orange horizontal line represents the mean of y, and the orange vertical line represents the mean of x. Now, let us consider a data value right here. This one is a particular observation labeled as xy. So, the difference between the observed value of y and the mean of y is actually what we called the total deviation. And then, this portion between the y prime and the mean of y is what we called the explained deviation. On the other hand, this portion between the observed value of y and the y prime is what we called the unexplained deviation, or also known as residual. So from those deviations, we can actually calculate the variations. So basically, the total variation is calculated by summing the square of all the total deviation from our given data, or the summation of the square of y minus the mean of y. And similarly, the explained variation is calculated by summing the square of all the explained deviation, or the summation of the square of y prime minus the mean of y. And lastly, the unexplained variation is calculated by summing the square of all unexplained deviation, or the summation of the square of y minus y prime. So next, let us proceed to the coefficient of determination. The coefficient of determination is a measure of the variation of the dependent variable that is explained by the regression line and the independent variable. The symbol for the coefficient of determination is r squared, and it is usually expressed as a percentage. And the formula in finding coefficient of determination is r squared is equal to explained variation over total variation. So the coefficient of determination is actually the ratio of the explained variation to the total variation. It is used to find how many percentage of the total variation is explained using the independent variable. And if the regression line passed exactly through every point on the scatter plot, it would be able to explain all of the variation. The farther the line is from the points, the less it is able to explain. So, coefficient of determination also measures how good the regression line is. Then next, coefficient of non-determination. If the variation in the dependent variable is accounted for by the variations in the independent variable, the rest of the variation is unexplained. This value is called the coefficient of non-determination and is found by subtracting the coefficient of determination from 1. So, coefficient of non-determination is the percentage of variation which is unexplained by the regression equation, which is equal to 1 minus r squared. But we can also calculate coefficient of non-determination by dividing the unexplained variation by total variation, if our r or r squared is unknown. Now let us proceed to our examples. So for example number 1, the question is, find the total variation, explained variation, unexplained variation, coefficient of determination, and coefficient of non-determination of the following hypothetical regression model. So we have here values of x and y, and the equation of the regression line is y prime is equal to 4.8 plus 2.8x. Now for our step 1, let's find the total variation. To do this, we need to find first the mean of y. So mean of y is equal to 10 plus 8 plus 12 plus 16 plus 20 all over 5, which is equal to 13.2. Then next, we can now substitute the values of y and our computed mean of y to the total variation formula. So the square of 10 minus 13.2 is equal to 10.24. The square of 8 minus 13.2 is equal to 27.04. The square of 12 minus 13.2 is equal to 1.44. The square of 16 minus 13.2 is equal to 7.84. The square of 20 minus 13.2 is equal to 46.24. Then the summation of the square of y minus the mean of y, or our total variation, is equal to 92.8. Next, for our step 2, let's find the explained variation. To do this, let's substitute the values of x to the regression equation so that we can find the predicted value, or our y prime. So for x is equal to 1, y prime is equal to 7.6. For x is equal to 2, y prime is equal to 10.4. For x is equal to 3, y prime is equal to 13.2. For x is equal to 4, y prime is equal to 16. For x is equal to 5, y prime is equal to 18.8. Then we can now substitute the mean of y and the predicted values of y to our explained variation formula. So the square of 7.6 minus 13.2 is equal to 31.36. The square of 10.4 minus 13.2 is equal to 7.84. The square of 13.2 minus 13.2 is equal to 0. The square of 16 minus 13.2 is equal to 7.84. The square of 18.8 minus 13.2 is equal to 31.36. Then the summation of the square of y prime minus the mean of y, or our explained variation, is equal to 78.4. Next, for our step 3, let's find the unexplained variation. To do this, let's substitute the values of y and the predicted values of y, or our y primes, to the unexplained variation formula. So the square of 10 minus 7.6 is equal to 5.76. The square of 8 minus 10.4 is equal to 5.76. The square of 12 minus 13.2 is equal to 1.44. The square of 16 minus 16 is equal to 0. The square of 20 minus 18.8 is equal to 1.44. Then the summation of the square of y minus y prime, or our unexplained variation, is equal to 14.4. Now let's check if our computed total explained and unexplained variations are correct. So our total variation is equal to 92.8, explained variation is equal to 78.4, and unexplained variation is equal to 14.4. So 78.4 plus 14.4 is equal to 92.8, which is also equal to our total variation. So our computed total, explained, and unexplained variations are correct. Now let us proceed to our step 4. Let's find the coefficient of determination. So r squared is equal to 78.4, which is our explained variation, over 92.8, which is our total variation. That is equal to 0.845 or 84.5%. So this result means that 84.5% of the variation in the independent variable is accounted for by the variations in the independent variable. Then lastly, for our step 5, let's compute the coefficient of non-determination. So 1 minus 84.5% is equal to 15.5%. Then this result means that the rest of the variation, 15.5%, is unexplained and can be due to sampling error or other variables. Now let's proceed to our example number 2. The question is, find the total variation, explained variation, unexplained variation, coefficient of determination, and coefficient of non-determination of the following hypothetical regression model. So again, we have here values of x and y. Then the regression line for this data is given by y prime is equal to 6 plus 2x. So for our step 1, let's find the total variation. To do this, let's find the mean of y first. So mean of y is equal to 22 plus 28 plus 42 plus 48 plus 40 plus 48 all over 6, which is equal to 38. Then let's substitute our computed mean value of y and the values of y to the total variation formula. So the square of 22 minus 38 is equal to 256. The square of 28 minus 38 is equal to 100. The square of 42 minus 38 is equal to 16. The square of 48 minus 38 is equal to 100. The square of 40 minus 38 is equal to 4. The square of 48 minus 38 is equal to 100. Then our total variation is equal to 576. Next, for our step 2, let's find the explained variation. So let us find first our predicted values. To do this, let's substitute the values of x to our regression equation. So for x is equal to 10, y prime is equal to 26. And again, for x is equal to 10, y prime is equal to 26. For x is equal to 20, y prime is equal to 46. And again, for x is equal to 20, y prime is equal to 46. For x is equal to 19, y prime is equal to 44. For x is equal to 17, y prime is equal to 40. Then we can now substitute the mean of y and the predicted values of y to our explained variation formula. So the square of 26 minus 38 is equal to 144. The square of 26 minus 38 is equal to 144. The square of 46 minus 38 is equal to 64. Then again, the square of 46 minus 38 is equal to 64. The square of 44 minus 38 is equal to 36. The square of 40 minus 38 is equal to 4. Then our explained variation is equal to 456. Then for our step 3, let's find the unexplained variation. So let's substitute the values of y and our computed predicted values of y to our formula. So the square of 22 minus 26 is equal to 16. The square of 28 minus 26 is equal to 4. The square of 42 minus 46 is equal to 16. The square of 48 minus 46 is equal to 4. The square of 40 minus 44 is equal to 16. The square of 48 minus 40 is equal to 64. Then our unexplained variation is equal to 120. Then let's check if our computed variations are correct. So our computed total variation is equal to 576, explained variation is equal to 456, and unexplained variation is equal to 120. So 456 plus 120 is equal to 576, which is also equal to our total variation. So it means that our computed total, explained, and unexplained variations are correct. Now let us proceed to our step 4. Let's find the coefficient of determination. So r squared is equal to 456, which is our explained variation, over 576, which is our total variation. That is equal to 0.79 or 79%. So this result means that 79% of the variation in the dependent variable is accounted for by the variations in the independent variable. Then lastly, for our step 5, let's find the coefficient of non-determination. So 1 minus 79% is equal to 21%. So it means that the rest of the variation, 21%, is unexplained and can be due to sampling error or other variables. Next, for our example number 3, the question is, the value of the correlation coefficient for the number of absences and the final grade of the 7 students in the statistics class is R is equal to negative 0.944. Find the coefficient of determination and non-determination and explain the meaning of each. So for this example, correlation coefficient is given, and we need to find the coefficient of determination and non-determination and explain the meaning of each. So we don't need to find the total and explain variation since R is already stated in our problem, and we just need to square it to find the coefficient of determination. Now let's solve. For coefficient of determination, r squared is equal to negative 0.944 squared, which is equal to 0.8911 or 89%. Then for our coefficient of non-determination, 1 minus 89% is equal to 11%. So it means that about 89% of the variation in the final grades can be explained by the number of times a student is absent, and the other 11% is unexplained and can be due to sampling error or other variables such as intelligence, amount of time studied, and etc. Next, for our last example, example number 4, the question is, the value of the correlation coefficient for the age of 30 drivers and the distance each driver can see is R is equal to negative 0.801. Find the coefficient of determination and non-determination and explain the meaning of each. So for our coefficient of determination, R squared is equal to negative 0.801 squared, which is equal to 0.6416 or 64%. And for our coefficient of non-determination, 1 minus 64% is equal to 36%. So it means that about 64% of the variation in the seeing distance reduced by taking into account the age of the driver, and the other 36% is unexplained and can be due to sampling error or other variables. So that's the end of my report. Again, I'm Carmela F. Ambrosio, and thank you for listening.